Let's begin by looking at the background plugin code that is generated by the template. This serves as a good starting point. The first thing we must do is to be able to react to changes in the configuration. There is a built-in message called Configuration Changed Indication that we are going to register to receive the init method. Let's also add the member variable for this object. Here we have defined the message registration, which includes the event handler that we haven't implemented yet, followed by the message registration. Let's add any missing using statements. We also remove the rest of the template-generated code from the init method. Finally, we want to unregister this message registration when closing the plugin. Now we can create the event handler. There are a number of items that this event handler depends on, so let's first create the needed member variables. Stop event is an auto-reset event signal that will be fired when closing the plugin, or if the configuration changes. Stop thread is a Boolean that indicates the state of a connection to a controller. Connected controller is the one that we are connected to. Client will be used by the communication methods that we will add after taking a look at the event handler. In the event handler code, we are first checking if any items exist of the given kind. In the following if statements, we make sure that items exist and the items are enabled and have a non-null IP address. As you can see, we only connect to the first item, regardless of how many exist. This keeps our example code simpler. In a real-world application, you would loop through each item. A new thread is started to connect to the given controller. The controller COM method will handle that. Let's paste in all the code for the communication part. Just to reiterate, this is the part where you are the expert about your own system and how to communicate with it. This example code allows us to simulate a very simple scenario of sending and receiving commands, so we won't dig deep into it. Feel free to look at the code on your own. It's standard TCP listener and TCP client communication. The two relevant parts in the communication code are the send command method that we can use to send a string to the controller, and the handle event method, which is called from the controller COM. We have not yet implemented handle event, but it will be used for handling incoming events from the controllers. For now, we'll just comment out that part and use the logging mechanism so we can confirm that we are receiving data from the controllers and that the communication is established. Before testing, let's go back to the close method and disconnect from any controllers. Finally, we remove the run method because we don't need it. Now we can build the project so we can test. You already know how to do it, so we won't go over it again. As we can see, there are two buttons that allow us to simulate sending events to our background plugin. The buttons are disabled until a connection is made from our background plugin. The message box above is to echo any commands that the application receives from the background plugin. When we restart the event server, we should see that the buttons become activated shortly thereafter. This confirms that the background plugin is able to get the item IP address from the configuration and is able to connect to the simulator application. Now, let's open the event server log and see if we can receive commands from the controller. Let's press one of the buttons in our controller simulator application while monitoring the logs. We should see a new line with our plugins identifier. As we can see, the first button sends the message Controller Up, and if we press the other button, it sends the Controller Down message. Excellent work! We have the communication framework set up and will continue with defining how to react to the events from the controllers.